can go ahead and bingo, there we go. All right, so I'm going to share my screen here. And did that work?
We see it.
Okay, outstanding. Sweet. Okay. You can go ahead and put questions in the chat function, but I will not see them until the end because I can't see the chat as we're doing this. So let's go ahead and start. As Deborah mentioned, actually it was Chair French, we're going to go through just the high-level top material changes in Order 1920A. It was a long order. There were lots of clarifications and lots of changes. And I'm happy to talk about that individually if anybody wants to about the other changes. We're then going to go into scenario planning, and I'm going to talk about scenario planning generically and how it's been used worldwide. Then we're going to go into an example from MISO, their most recent scenario planning process that's resulted in a $30 billion portfolio of projects that is going to the board of directors tomorrow. And then lastly, talking about where states have the best levers to influence the scenario planning process under Order 1920. All right, so first we're going to do 1920 cost allocation changes. And really, guys, I don't know, was it 800, 900 pages? There's a lot of clarifications and changes. I'm only hitting some top line ones. Probably the most important one for the relevant state entities is you now have the opportunity, if you need it, you're going to have to prove that you need it, to request a 6-month extension to the original 6 months. So for a total amount of 12 months for the engagement period, that's a really fantastic change. FERC also made it clear that the RSCs can now propose their own ex-ante methods during the engagement period. And you can develop a state agreement process. And the transmission providers have to submit that to FERC. Now, mind you, the transmission providers don't need to endorse whatever the RSCs do, but they at least have to submit it to FERC for FERC's consideration. The transmission providers, of course, can and probably will be submitting their own proposals as well. And so FERC is going to have to decide what, or maybe adopting all of them. All right. So the role of the states in 1928 have been really increased. One of the things that the RSCs can do is they can request from the transmission providers that during the engagement period, the transmission providers essentially facilitate and participate in cost allocation discussions. This is important because maybe not everybody realizes this yet, but cost allocation discussions are quite difficult. It takes a lot of expertise, and of course, the transmission providers should have that expertise. So inviting them in, but also controlling them, would probably be in the RSC's best interest unless you already have your own internal expertise. Also, FERC indicated that the RSCs, that's the relevant state entities, can ask the transmission providers to conduct additional analyses to inform cost allocation discussions. And that's essentially what they specifically said was you can ask for additional scenarios. You're only allowed to ask for a reasonable number. And I do want to point out, as you're going to see when we get to the MISO example, it takes a long time to run additional analyses. So the question is if they're going to be able to complete that in a timely manner. That is the big question on that. But bottom line is RSCs now have a new power to ask for additional analyses so that you can start to parse out the benefits and the beneficiaries of any selected facilities during the planning process. Now, the SAP, which is the state agreement process, is this, if you recall from the last presentation, it's the process that the RSCs are going to create that's run after compliance. Now, if the transmission providers either want to change the cost allocation methods that were approved by FERC, or if they want to change the state agreement process that was also approved by FERC, the providers must provide the RSCs the opportunity to provide input to that. And FERC also indicated the RSCs can prompt amendments to one or both of those in the future. FERC made clear that the PJM agreement approach, so the PJM agreement approach, and there are some people from PJM in here, that it was adopted and approved by FERC outside of the Order 1000 process. And what FERC said was, look, the PJM agreement approach is still valid outside the context of both Orders 1000 and 1920. They explicitly said if OPSI or PJM wants to submit that as a cost allocation methodology under Order 1920, they can do so. They made no indication as to whether or not they would approve it or not. Another clarification, and it was explicitly stated in Order 1920A, is that voluntary funding methods are not prohibited under Order 1920. And the TPs, transmission providers, or the RSCs can submit voluntary methods on compliance. So let's jump to the planning changes. So just as in cost allocation, the RSC's role in scenario planning has also been improved in Order 1920A. So the language has been strengthened. The providers, the planners, must consult with and consider the position of states relating to laws, policies, and regulations. That's a more robust kind of consultation that was required in 1920. And they explicitly said, and this is quite important, that for states with integrated resource plans, the scenarios have to include at least one of the trajectories that the IRPs would indicate in the scenarios. If you recall, in Order 1920, there are 7 categories of factors. Essentially, there are 7 types of assumptions that go into the scenario planning effort. One of the categories included corporate goals, and to try to not double count corporate goals, FERC eliminated that from the 7th category of factors. They did explicitly say, however, if corporate goals are not captured elsewhere and they will affect the needs of the transmission grid, then they do have to be included in the modeling as a separate category. All right, new. I'm laughing because FERC orders seem to be interpreted a number of different ways by a number of different people, but I'm pretty sure what this one says, the first bullet, is that, look, what FERC had done first is they said you had to use the 7 benefit metrics to identify needs. And everybody who does planning pushed back and said, well, you don't actually use the benefit metrics to identify needs. And so FERC said, you're right, you don't have to use the benefit metrics to identify needs. Instead, the needs analysis should rely on the economic and reliability drivers. So in other words, economic planning models, reliability planning models is what should drive the identification of the transmission needs and the improvements to the transmission grid. Transmission providers are now strongly encouraged to consider state-supported selection criteria, which again is a strengthening of the state's role. And the very first planning cycle, now, it used to be that it was just 1 year after the compliance deadline, and FERC extended that to 2 years. So let's just get a sense as to what the compliance timelines very likely are going to be. I'm assuming most RSCs are going to ask for the 6-month extension, and this timeline assumes that. So that means the compliance deadline is automatically extended for the transmission providers to December of 2025. The initial planning cycle then starts no later than December of 2027. That's 2 years after the compliance deadline. And it's got to end then 3 years later, December 2030. And the second planning cycle then must begin no later than 5 years after the beginning of the initial planning cycle. So we're looking at 2032. Nothing ever happens fast in our world. All right, scenario planning. What the heck is it? Some of you might be bored if you're in MISO, but here we go. So as we know, the future is always uncertain. And one of the critiques of transmission planning is the future is uncertain. How can you identify infrastructure that's needed 20 years out, given that uncertainty? Scenario planning is one way to do it, and it's used worldwide. It's especially useful when the level of uncertainty is high, when the technologies are rapidly changing, and it takes time to essentially design and build the new infrastructure you're looking for. I mean, if you think about it, if regional transmission lines take 8 to 15 years to design and build, you got to plan at least 20 years out. So how do you do that in a way that gives you, the regulators who are paying for this infrastructure through the utility rates, how do you get comfort that your transmission planners are actually selecting the right facilities? Let me just say that scenario planning is used worldwide. It's actually been used less in the US recently. Royal Dutch Shell started using it in the 1960s during the oil crisis for their infrastructure plans. RAND Corporation then developed its own kind of long-range forecasting that is being used by governments worldwide as well as the military. So this is not a new process, and it's been used for a long time. All right, so what is scenario planning? The very first thing you do, and I like to think of scenarios, or some MISO calls them futures. I like to think of them as hypothetical future worlds. So you're thinking, if we were doing it, let's say, starting in 2025, what is the world in our industry going to look like in 2045? And that's what you're trying to figure out. So what you want to do is you want to get a range of plausible, diverse, and the inputs need to be based on trends, current data, but you're looking at 3 different hypothetical worlds for 2045. And, the changes are different kind of generation resources, potentially different locations for those resources, different load, right? We know that load is changing quite a lot now. Different kinds of demand response penetration, different EVs, et cetera, et cetera. All these things change, but you want the scenarios to make sense. So each scenario by itself has to be plausible, and then you have to have a range of plausible scenarios. And the reason you do that is that's going to give you comfort that you're actually capturing the probable future, right? And ultimately, let me just get this, after you finalize the future, you identify the needs created in each one of those futures. So in other words, you've got different, as an example, you've got different generation portfolios in each of the 3 different futures. And you're designing a different transmission grid to meet those needs of the futures. Because one of the big challenges in the future is not just capacity, but it's going to be the deliverability of the new generators to the new and rapidly increasing load. So then you're going to, once you identify the needs, you're going to look at a variety of different solutions. And given the fact that you're going to have 3 different hypothetical worlds, the best case scenario is to find infrastructure that is going to solve the needs in all three scenarios. And that generally is what's called the least regrets approach. Would like to point out that orders 1920 and 20A not only require the transmission planners to take a look at what transmission improvements will resolve the needs, but they also have to look at, dynamic line ratings, advanced power flows, advanced conductors and transmission switching. In Order 1920A, FERC explicitly specified what kind of advanced conductors need to be evaluated by the planners. All right, so that is a basic overview of what scenario planning is. Now let's get into an example from MISO. Now this is an example from what MISO has done over the last 2.5 years that's led to the portfolio that's going to the board tomorrow for Tranche 2.1. Here's MISO's 7-step process, and it's essentially what I just described, though they use a little different language. So MISO, rather than hypothetical worlds or scenarios, they use the word futures. And so first they design the futures. They've designed 3 different futures for Tranche 2.1. Once they determine what generation resources are needed to meet the assumptions in those futures, then they have to cite the location of the new generation. Then they develop their planning models. They run both reliability and economic models to identify potential transmission issues and also solutions. So they iterate back and forth for the evaluation on how to solve the needs. Then ultimately they end up recommending solutions and then move into the appropriate cost allocation. Defining the futures. So as I indicated, FERC has identified 7 categories of factors that need to be considered in the scenarios. Now, I think of the factors as the assumptions in the modeling that ultimately leads to different hypothetical worlds. And so these are some of the examples of the kind of factors you're going to tweak between the three plausible scenarios to make sure that they're capturing different hypothetical worlds. So annual capital costs. That used to be a huge debate on what they should be, but MISO is now, they just use the moderate values contained in NREL's database. Retirements of generators, they use age-based criteria and announced retirements. For additions of generators, they use announced generators, and then ultimately when they run the models, when they run the resource expansion models, the model itself will identify additional generation to meet to ensure that the other assumptions are actually complied with. So it does capture distributed energy resources. MISO has moved to a pretty sophisticated natural gas price forecasting, which, the higher the demand on natural gas usually means the higher the price. And so this forecasting method actually calculates how much natural gas is going to be used, and then the price of that natural gas changes on the demand. Load, as we know, it's been somewhat unpredictable, but MISO has benchmarked it with an outside consultant. They did assume the Inflation Reduction Act would be complied with. Resource accreditation in MISO has been quite the debate. The resource accreditation, since this planning process started in 2022, the accreditations used in the 2022 planning resource auction are used. MISO is changing its accreditation, and I am assuming for Tranche 2.2, MISO will be using the new accreditations. I'm not going to read through this, but one of the key ones is the very last one: utility announced plans and IRPs. All right. So what does it mean? I just went through all some of the factors, not all of them, but some of the factors that are identified by FERC as being required in the scenario development. And this is what hold on a second. This is what it means when you start applying those factors. So I'm not going to go through all this, but for MISO, Future 1A was supposed to be the most conservative, and Future 3A was supposed to be the most aggressive, and then Future 2A somewhere in the middle. Now, as you can take a look at this, let's just look at electrification, growth, and technologies. I don't know if you guys can see that, but let's just look at this line right here, right? So they're assuming 2% growth in the most conservative, 15 in the middle, and then 31 in the most aggressive. The same thing with selected DERs, assuming just a little bit, a moderate amount, and then the most amount here. We're going to talk about the carbon reduction goals because fascinating result here, just given the utilities goals and how that actually drove the results. If you want to take a look at this later, these rate, can you guys see my cursor? Yes, okay,
yes,
good.
It's small, but we can see it.
Okay, you can take a look at this. This gives you, it's the legend for all of the different acronyms that MISO used on this sheet. And I would also urge you to just take a look at this futures report itself. The reason it's called Series 1A, it drives me a little crazy with all these 1As and 2As. Series 1A for the futures has nothing to do with this, with the nomenclature for the scenarios. Series 1A means it is the updated future, it's the updated series from tranche 1. It gets confusing. All right. Why am I now not going forward? There we go. So we talked about FERC's 7 categories of factors. Now, I want to stress that when taking a look at what factors need to go into your scenario development, the fundamental question is what factors will materially affect the need for transmission in 20 years, in 2045. So FERC indicated that there are 3 categories that are absolutely required and you cannot discount them. They are on the top. They're essentially governmental laws and regulation, governmental laws on the resource mix and demand. Then the second bullet is on decarbonization and electrification. And the third bullet is on IRPs and expected supply requirements for the load serving entities. Then the last 4 categories of factors, these can be discounted. And again, what's going to drive whether or not they're discounted is how they're going to materially affect the need for transmission in 20 years. So you've got fuel costs, the availability of storage resources, electrification technologies, resource requirements, GI requests. Now, as I indicated earlier in the last category of factors, FERC deleted corporate commitments. So right now it just reads utility commitments and governmental policy goals that affect transmission. Now, I'd like to point out that your providers on compliance can propose to FERC to use more than these categories. But we'll talk later, but identifying the categories and how the data is input into each of these factors is one of the critical roles that the state regulators can play during the engagement period. All right, let's get to a specific example. So MISO, as I indicated earlier, the decarbonization goals and commitments were pretty significant in the development of Tranche 2.1. If you look at the map on the right side, 80% The dark green states have 80% targets for decarb. Lighter green, 50%, and then we've got enforceable decarb goals and aspirational decarb goals. The bottom line is a large portion of the MISO footprint has really aggressive decarb goals. And what happened during Tranche 2.1 is, though the assumption, when they were assuming what level of decarbonization needed to happen, the middle future 2.A, it could never go below 60% of decarb. That was just assumed that was going to be pushed into the model. But what happened was, once they added up all of the member goals, it drove that to a 76% decarbonization. And then, once you included economic drivers in that middle future, Tranche 2.1 has a total carbon reduction of 96%, which is very, very aggressive. Now, these are, remember I indicated that, the very first step you do in developing your hypothetical worlds is you figure out all of these assumptions, you run the resource expansion model, and the resource expansion model kicks out what generators you're going to need, in this case for MISO, in 2042. Now, I will say MISO's modeling for Tranche 2.1 primarily relied on Future 2A. They did run and complete all the modeling for Future 1A. They did not complete the modeling for Future 3A. So arguably, they didn't run the least regrets kind of analysis that could have been run. But the reason was the modeling takes so long. So, MISO, I think they started this in the middle of 2022, and it's going to the board tomorrow. And MISO's been doing this process for over 15 years, right? Yes, well over 15 years. And it still takes them so long that they were unable to do the full modeling for Future 3A, in part because it was going to be difficult to get the Future 3A model to solve, just because of how different the generation portfolio is in Future 3A. All right, so you run the resource expansion model based on all the assumptions you put in it. You've got two different sets of new generation. The first set, at least in MISO, is the planned generation. And so that's just baked into the resource expansion model. The locations of the locations of the utility defined new generators are already known. So that's the map on the left-hand side. The resource expansion model, however, identifies the type of generators you need and the volume of the generation that's needed. And that's what's in the right-hand side. Now, the resource expansion models do not identify where those resources are located. So MISO has to work with the states and has to work with the utilities to find reasonable locations for that new generation, which is the map on the right-hand side. As you can imagine, there's lots of debates on the right-hand map, not the left-hand map. So after you have the location of the generators identified and the size of the generators, then you need to figure out how to, number one, deliver the electricity from those generators to load. But you also need to figure out, well, gosh, there's going to be, given how much new generation there's going to be a lot of overloads on our existing transmission system. And so I am not an engineer. I got this straight from MISO, but they run 3 different kinds of reliability models. steady state, transient stability, and transfer analysis to look at the reliability of the existing grid, because we know it's not going to be reliable with all this new generation. And then ultimately, they're also going to do that reliability model to test their proposed solutions. I'm just trying to give you a sense as to how complicated this is and why it takes so long. So these are the 3 different models that MISO has to build for reliability. They do one for 2032, 2042, and then they do transfer scenarios for 2042. So in addition to the reliability analysis, as FERC indicated, right, whenever you're determining your needs, you look at reliability and economic needs. So this is an example of the kind of economic analysis MISO does to determine the needs for new transmission. And again, it would also be used to identify the solutions. So what MISO then does is they iterate back and forth between reliability and economic analyses, not only to identify the needs, but then to evaluate and select solutions. Now, MISO right now just looks at transmission solutions. As indicated earlier, 1920 includes the requirement that the planners also take a look at, advanced conductors, power flow controls, etc. Interestingly, I don't think MISO has done that, and I think there's going to be some challenges in figuring out how to roll that in and be able to compare those solutions with transmission solutions. So it's going to be really interesting to see how the planners do that. But an absolute requirement and a great development, because as we all know, things like advanced conductors can save consumers a lot of money. So again, so we did develop the hypothetical worlds, run the resource expansion modeling, come up with the generators that you need, and then look at the needs, the problems that are created by all that new generation and load, and then start to identify solutions for that need. Now, MISO considers other things than just economics and reliability. So they, for Tranche 1, as an example, and a lot of Tranche 2, when they could, they co-located the new transmission lines with existing infrastructures. And that was in an attempt to minimize the environmental impacts and increase the viability that permits from the states would be issued. The amount of right-of-way is taken a look at. Legacy voltage versus changing voltage. For Tranche 2.1, as a general rule, especially in Western MISO, the legacy voltage has been 345 kV. MISO is switching over to 765 kV. So, pardon me, the legacy voltage is slowly changing, but that's one of the things to consider when you're selecting solutions. MISO also does what's robustness testing, which essentially is a sensitivity. And just to give you an example, there's a firm cutoff date when MISO's building their models and determining what existing transmission needs to go into those models. And the Grain Belt Express didn't meet the requirements to be in the baseline models. But what they did do was run robustness testing on Grain Belt Express. And essentially, this is what they did. They looked at what transmission they were proposing, and they added the Grain Belt Express line in to see if those lines were still needed after Grain Belt Express was added in. And the answer was yes. So that is one example of robustment testing. Right-sizing opportunities was also considered by MISO, which I think is one reason we have 765 now in a lot of states that never had it before. The requirement of MISO's cost allocation tariff is that the portfolio itself has to meet a 1.0 benefit to cost ratio. And indeed, tranche 2.1, which is based on future 2A again, the BC ratio ranges from 1.8 to 3.5. And what I'd recommend you do, I'm just trying to think. Unfortunately, MISO only had its draft MTEP 24 report out yet, but you may want to take a look at the final MTEP 24 report if you want to dig into this a little bit more. And this is tranche 2.1. It's the final plan based on future 2A, and it is going to the board of directors tomorrow. So you'll be seeing some press on what happens on Friday. Now, this kind of scenario planning takes a long time for even MISO that has been doing it for well over a decade. Now, just take a look at this. 40,000 hours of labor from MISO staff, 300 formal meetings, and numerous discussions with stakeholders. I don't even know, it's probably in the thousands. They started, if you look at the timeline, it's probably pretty darn small for you, and I apologize, but the futures refresh that's used in tranche 2.1 started in July of 2022. And it is going to the board of directors tomorrow. So the moral of this story is everybody needs to get working on the regional planning process under 1920 as soon as possible. So I do just want to talk about the Order 1920 evaluation processes and selection criteria. You know, FERC has indicated that the planners have to identify one or more facilities that address the needs that have been identified. They've got to estimate the costs and benefits for potential selection, and then they have to identify whether they select or don't select facilities. There is absolutely no requirement that the planners select facilities under Order 1920. That is up to the planners as to whether or not they do that. But regardless, the planners have to explain why they did or did not select facilities that were identified that address the needs. The criteria for both evaluation and selection obviously has to be transparent and not discriminatory. Benefit to cost ratios can't be higher than 1.25. And they say, look, the transmission providers have a lot of flexibility in how they measure the efficiency and cost effectiveness, but FERC stressed time and time again, number 3 at the very bottom, that the planners have to seek to maximize benefits of costs over time without overbuilding transmission. All right, so what can you guys do? You can do a lot and should do a lot. First of all, as indicated, the engagement period can be extended for up to a year if you need to, given the complexity of this, especially in areas that have never done it. I suspect you're all going to need it. So the factors, so now we've talked about the factors that go into the scenarios and then the actual inputs that are essentially the data that fills in to the models. It's absolutely critical. It's what's going to drive the resource expansion planning. And you have a lot of opportunities to provide input to the transmission planners on these. And if you want to take a hold of your own destiny, you should indeed be actively involved in that. So Order 1920A increased your ability. The language says that the states have a real meaningful role in defining the scenarios and the inputs. So meaningful opportunity to provide timely input, including factors and data inputs. FERC indicated they really want states to explain how their state policies and planning affects the needs of the grid. Looking at the second bullet here, the planners must consult with and consider the ROC's positions on factors relating to laws, policy, and regulations. Providers shall consult with ROCs on how state policies are going to be accounted for, how the policy will be used in the development of scenarios, and how to adjust the treatment of specific policies across the scenarios. So in other words, again, we want a range of scenarios. You've got your policies. Those can be discounted or they can be considered, 100%. So the planners need to talk with you about how to spread across essentially consideration of your policies amongst the at least 3 scenarios. And IRPs are now very important in that FERC has indicated that IRPs really the trajectory that is defined within the IRPs on supply and demand have to be captured in the scenarios. The providers, I'm now down at evaluation and selection criteria. Good faith efforts to consult with and seek support from the ROCs. And lastly, also a change in 1920A, providers are encouraged to consider any selection criteria supported by the ROCs. And this is the same message I gave at the last time. The engagement period is really important. It's a significant opportunity for you to influence the future of your state. And I hope you've taken away from my description of the MISO example on scenario planning that it's really complex and it takes a long time. So start now. All right, with that, I'm going to stop sharing, and I think we need to stop recording. And I'm just looking at the Q&A right now. Yes, the slides will be shared.